in the first question, you can see a reaction is given and it is asking us to calculate the EMF of the cell. And in the reaction, you can see the molarity of the particular species. So 0.002 molar is the concentration of the silver ions, and 0.160 molar is the concentration of nickel ions. And how to calculate the how to calculate the EMF of the cell? By using the Nernst equation. So everything is given here, the concentration of the ions and standard electrode potential is also given, so we can calculate the cell potential very easily by using the Nernst equation. So the Nernst equation is E cell equal to E naught cell minus 0.059 by 2 log of ions present in the anode divided by concentration of the ions present in the cathode. And one, you can see that the 2 is given, so this will be the power, whatever is there coefficient, okay, stoichiometric coefficient will go as the power here. Okay, if here it was 3, then it here if it is 3, it will go here 3 to the power 3. So this thing you have to keep in mind. Okay, don't forget about the coefficient. So coefficient will become power of the concentration. And this is the anion present in the anode side, this is the cation present in the anode side, and this is the cation present in the cathode side. Okay, so E naught cell is provided in the question, that is 1.05. then again you have to put this log of concentration of nickel ion is given within bracket, you have to put that value, and again for silver ions as well you can put the value square. Okay, so after calculation you will get, you will be given a log table. So after taking log of that particular value you will get 4.602. you can calculate this, I hope. Okay, so you try to calculate this one, then you can get the value. So basically in chemistry you don't have to look what the question is, just try to understand how to solve a particular question. Okay, so you have to know the method instead of knowing the sum, because this same question might not be in the examination, but once you know how to solve the question, any question that comes you can solve it. Okay, so this is the main motive of solving the numericals in the class. The next question, one reaction is given and E naught cell is given. We have to take out the standard Gibbs energy and equilibrium constant. So here also you can use the direct formula. So for the relation between delta G, which is Gibbs energy, and E naught cell, which is the standard electrode potential, the relation is delta G naught equal to minus NF E naught. For N, that is the number of electrons involved, which we'll see now. F, you have to remember the value, that is 96500 coulomb, and the E naught is given in the question. So how to calculate the small n now here? Okay, so here this is the number of electrons involved. If you can recognize from here, it's fine. Okay, so only one reaction you see here, it's given 2. Okay, 2 iodide ions are there, and here I2. It directly signifies that the number of electrons involved is 2. Everywhere the coefficient is 2. Okay, so this is how you can recognize. Otherwise it is difficult for you, then you can use one another method, that is, first of all it's given that I negative is converted to I2. Okay, it means I negative is converted to I2. Now this is what an oxidation reaction, right? Because from negative to positive it is going. Okay, the value is increasing from -1 to 0, the value is increasing, right? So this is your oxidation. It means this iodide ion has released 1 electron, so that iodine is formed. But as you can see here, there are 2 iodine atoms, so here you have to put a 2 here. Okay, now again you see 2 negative is there, but only 1 negative, only 1 electron is there. No, charge is not balanced, so here you have to put a 2. Now this is complete, so you know this is oxidation. And another one is given, Fe3 plus is converted to Fe2 plus. So this is the equation that is given here. Fe3 plus is converted to Fe2 plus. Now if you can see here, from plus 3 to plus 2, so the value is decreasing, no, from plus 3 to plus 2. So this means what? It is undergoing reduction. And how many electrons it requires? Only -1 is required, means only 1 electron. So it will require 1 electron in order that Fe3 plus converted to Fe2 plus. Okay, ferric to ferrous. Now when we are going to do the overall put the total reaction, you can see that this electron must be get cancelled, right? So here you have to multiply with a 2. So if you multiply the whole reaction with a 2, you have to put here 2, here 2, and here 2. Clear? So now this and this will get cancelled and you will get the reaction as it is given in your book. So how many electrons are involved here? 2 electron is involved, right? So this is how you take out. Clear? Otherwise it is very easy to recognize from the reaction. I'm just showing you how to do the things properly. Okay, so now you put the value of N as 2 and then you put the values of F and E that is given in the question. You will get the answer as minus 45.55 kilojoule. Clear? Now Kc that is your equilibrium constant. Another formula you have to use, that is delta G not equal to minus 2.303 RT log Kc. Put the value for this that we have taken out now, minus 45.55 kilojoule. Then you bring the log Kc this side and do the division. Okay, now after getting a value that is 7.983, you will get Kc equal to, have to bring the log that side, no, it will become anti-log. So you will be given a log table, and in mathematics you will learn how to do the log and anti-log. Okay, so that is not the matter. Now you just have to know how to solve the problem. Okay, what formula you have to use in order to solve it. So this was a very easy example. Here direct formulas are used, and this question may be of 2 marks only, 2 or 3 marks. Okay, 1/2 this for this part and 1/2 for this part. Okay, and the values will be provided, so no worries about it. Okay, anti-log and log table will be given to you. Now in order to move on to the next question, we have to understand one thing here. So I have given you a equation that is A2 plus 2 electrons will give us A. A means what? The charge is here neutral. Okay, it is 0. So it means what? If there is a plus 2 here, in order that I make it 0, what I have to do? I have to do minus 2. Minus 2 means 2 electrons, isn't it? And now here you have to remember one thing. 2 electron means 2F. F is Faraday's constant. So what may be the number of the charge, that is N plus. Okay, suppose in general terms, suppose it is N plus. Whatever the charge is there, that many number of electrons you have to put in order that it is converted to B. Okay, neutral charge. Suppose I am taking plus 100. I have to make it 0. I will put here minus 100, right? So that means 100 electrons, which means 100 Faradays. Okay, clear? So let us move on to the next question now. It's given here how much electricity in terms of Faraday is required to produce. Means you have to take out the Faradays of electricity. In the first equation it's given 20 gram of calcium from molten CaCl2. So CaCl2, calcium, you know it's Ca2 positive, right? So they are asking us to calculate for calcium, means Ca2 plus is there, Ca2 plus. So how many electrons is required to convert to Ca? 2 electrons, it means 2 Faradays. Okay, so that thing you remember. Here you can write the sentences: 1 mole of calcium, that is 40 gram. Okay, the atomic mass of calcium is 40, so you can write 40 gram. How much electricity is required? It means for converting from Ca2 plus, this is what is the atomic mass of calcium, 40. For 40 gram, 2 Faraday of electricity is required. So for 20 gram, how much you will require? So it will be 2 into 20 divided by 40. Unitary method you have to use here. Okay, next one is for aluminium, and the question is 40 gram of aluminium from molten Al2O3. So Al3 positive, with that you have to add 3 electrons, you will get aluminium, so 3 faradays. Now the atomic mass of aluminium is 27. For 27 gram you require what? 3 faraday of electricity. Then for how much is given? 40. So for 40 gram of aluminium, how much you will require? 3 into 40 divided by 27, so it is 4.4 faraday. I hope this is clear. Now it is asking how much charge is required for the following reduction. Okay, now it is simple. You see Al3 positive, you have to put here 3 electrons. Okay, aluminium will be produced. Okay, aluminium metal you will get. Now again you have to use the same method here, but now you have to see here that 3 faradays, no, so 1 faraday is 96500 coulomb, right? So 3 faradays will be 96500 into 3 coulomb. So like that you have to solve the question. I hope you have understood this. If you have understood this, you can understand this. Only the thing is that one extra step is there. 1 faraday equal to 96500 coulomb, so you take out for 3 faradays. Clear? Then you can proceed on the method. Again here you have to do 2 faradays of electricity, no, so 2 into 96500 coulomb means you have to take out in coulomb. That is the point. If it is asking in charge, you have to take out in coulombs. Okay, and they might ask also that charge in coulombs. Okay, they have asked here faraday, so we have taken out in faraday. One thing you can do here, no, at last you take out, okay, the way that you have done here, you take out here, then you will get here some value now, 1 faraday, 4.4 faraday, then you multiply with 96500. That will be easier. Okay.